When we're working with unpleasant numbers in the quadratic formula, the most likely source of error is copying error, either copying on paper or punching the wrong button when we plug into the calculator. One of the ways we can mitigate this source of error is to use the calculator's variable storage function. Store our unpleasant numbers as variables in the calculator, and then punch in the quadratic formula just looking the way that it looks. So here I've got the process written out. We'll store our values of A, B, and C using the alpha key to put in the letters A, B, and C on the calculator. Then it's best to stop off at computing the discriminant, partially because that's going to save you some entry error in the quadratic formula, partially because before you plug into the quadratic formula, you want to look at the discriminant and see if it's positive, 0, or negative, so you know how many solutions to expect. And then finally, we're going to punch in negative b plus the square root of the discriminant divided by 2a, negative b minus the square root of the discriminant divided by 2a to find the two solutions. So here's an example of that. And normally when we do calculator things, I just show you the calculator screen. In this case, I'm also going to show you the calculator keypad because in particular, I want us to focus on how we're entering the letters. For the filled notes, I've pasted in an image of just the keypad of a TI-84. And I want to call your attention to the green alpha key, and then above each key in green, a letter of the alphabet. When we press the alpha key, followed by the key underneath the letter, that gives us that letter of the alphabet. So if I press, for example, alpha, notice the cursor turns into a letter A, followed by the exponent key, I get H. If I say alpha sign key, I get an E. Alpha parenthesis, alpha parenthesis for two O's, alpha 7 for an O, I get hello. And then I hit enter and it spits out some number. Because what the calculator is thinking when it sees a letter is this is a variable with a number stored in it. By default, when you first powered on your calculator for the first time, every variable has the number 0 stored in it. But after a while, it's whatever was stored in that letter most recently. So for the quadratic formula then, we will store our values of A, B, and C in the letters A, B, and C, and that will let us enter things into the quadratic formula just the way that they look. So let's get this problem set up a little bit more before we start hitting buttons on the calculator. A company determines its profit in millions of dollars from selling X million widgets with this function. We want to know how many widgets should they sell to make a profit of this much money. So this is saying P of X is 50.1. So negative 0.06 x squared plus 3.8x equals 50.1. To get standard form, we'll subtract 50.1 from both sides. Negative 0.06 x squared plus 3.8x minus 50.1 equals 0. So we'll have A is negative 0.06, B is 3.8, and C is negative 50.1. Now going to the calculator, I want to enter my numbers. So I'm going to start by typing in negative 0.06. And then the key I'm going to use is this key labeled STO. That stands for store. I'm going to hit the store key, and then I'm going to say alpha A. I hit enter, and it just shows me that number that I entered again. That's showing me what I just stored. I'm going to do the same thing for B, 3.8, store alpha B, enter, negative 50.1, store alpha C, enter. The next thing I'm going to do is compute the discriminant. And I'm going to do that for two reasons. One, I want to have it stored on the calculator, so I don't need to type in b squared minus 4ac over and over again. Two, before I go any further, I want to make sure that I'm going to have real solutions. So I'm going to say alpha b squared minus 4 alpha a alpha c, and I'm going to store that to alpha d. I'm going to store that to the letter D for discriminant. My discriminant is 2.416, which is greater than 0. So I know I'm going to have two real solutions. And now I'm going to get decimal approximations for them. I'm going to say parentheses, the opposite of alpha b, plus second x squared for the square root of alpha d, close parentheses, divided by 2 alpha a, close parentheses, enter. And the instructions told me to round to one decimal place. My first solution is x is approximately 18.7. For the second solution, instead of plus the square root of d, I want minus the square root of d. I could type the whole thing in again, or I can use the up arrow twice, select that formula and hit enter, and then use the left arrow to put the cursor over the plus sign, change it to a minus sign, hit enter again. My second solution, x is approximately 44.6, again rounding to one decimal place. And of course we can check these. We have p of 18.7 is negative 0.06 times 18.7 squared plus 3.8 times 18.7. Working that out on the calculator, we have 50.0786, which is indeed very close to the 51 that we wanted. Plugging in p equals 44.6, we'll have negative 0.06 times 44.6 squared plus 3.8 times 44.6. And that's exactly 50.1304, which is again very close to the 50.1 we wanted. So using the variable storage on the calculator gives us an easy way to avoid copying and recopying these unpleasant numbers, and lets us find decimal approximations for our solutions relatively quickly. We should only use this technique when we're trying to get decimal approximations for our solutions, not when we're trying to get exact answers in terms of square roots.